Hello everybody, welcome to today's video lesson. Today we're going to be talking about properties of logarithms. All right. After this lesson, we'll be able to evaluate expressions and solve logarithmic equations using our properties of logarithms. All right. So let's hop right into it. Okay, we have three properties we're going to go over in this video. We're only going to prove two of them, but we can prove the third one with very similar thinking. Okay, so we're going to do one on the left-hand side and one on the right-hand side here. And we're going to start them both off with these two truths here, and we're going to let a raised to the x power equal b, and we're going to let a raised to the y power equal c to start both of these off. Okay, so starting here on the left-hand side, okay, a to the x equals b and a to the y equals c. Well, if that is true, then a to the x times a to the y must equal b times c. Okay. And if that is true, well, what happens here if I have two of the same base raised to these exponents here? What do we do with that? And we're multiplying these. We're multiplying these terms. Well, if you remember with our exponents, when that's the case, we're going to add them. Okay, so this is a raised to the x plus y power equals b times c. Okay. Now I'm going to go ahead and take the log of both sides, and I'm going to take the log of base a because I have this a right here, okay? Because I have a base a that's being raised to this x plus y exponent, okay? So I've got log base a of a raised to the x plus y power equals log base a of b times c, okay? Okay, so if I have that, log of a base with the same whatever the base is, so I've got log base a of a, okay, that's just going to be whatever this exponent is, okay, and we've seen that in a previous video. So that's just going to be, I'll bring it back here, that's just going to be x plus y. That's just that exponent. Whatever this exponent is what this equals to, okay, and that's equal to log of a of b times c. Okay, nothing changes on the right-hand side. Okay, now we need to go back up here and think about what this means in terms of logarithms. Okay, well, if I take a look at this exponential equation here in terms of a logarithm, okay, I know that log base a, okay, remember my base stays the same, so log base a, okay, and then my exponent comes to the other side of my equal sign, and whatever our final result is, that's what goes inside our log, okay? Because remember, when I take a look at my logarithms, this would be a raised to what power equals b, okay? So a to the x power equals b, and same here with a to the y equals c. Okay, so all I'm doing is rewriting these original truths that we're using for this proof in logarithmic form, all right? Okay, so all I'm doing here is I'm going to substitute now I'm going to substitute log base a of b for x, since those are equal to each other, and for y, I'm going to substitute log base a of c, okay? And we get that log base a of b plus log base a of c equals log base a of b times c, okay? So what this shows us is that if I have log of some base, and inside my log I have multiplication, I can break that out into individual logarithms with addition separating them, okay? Okay, so let's take a look now. That's our product property, okay? So let's take a look at our quotient property, and we'll summarize all these in the next slide, okay? So I've got the same starting point here, okay? A to the x equals b, a to the y equals c. Okay, so if this is true, then a to the x divided by a to the y must equal b divided by c, okay? And if that's true, do you guys remember what we do here if I have the same base raised to these exponents? Hopefully you remember. If that's the case, we're going to subtract them. Okay, over here we're multiplying, so we added them. So here we're dividing, so we are subtracting our exponents now. Okay, so I can rewrite this left-hand side of my equation as a to the x minus y, and then nothing changes with b divided by c, okay? Okay, now again, I'm going to rewrite this in logarithmic form. So I'm going to not rewrite this in logarithmic form, sorry. I am going to bring in a log base a, again, strategically doing that because I have this base of a that's being raised to the x minus y exponent. Okay, so I take log base A of both sides, right? And then again here, log base A of A is just whatever the exponent is, okay? So that's going to be x minus y, okay? So this whole side will simplify to x minus y. Nothing changes on the right-hand side. Again, taking a look at my original starting equations here in logarithmic form. So log base A of b equals x. Okay, that's just rewriting this in logarithmic form. Okay, and same here. Okay, and then all I'm doing is I'm substituting log base A of b for x, log base A of c for y. Okay, and we can see that our final property shows us, whenever it pops up here, there we go, log base A of b minus log base A of c equals log base A of b divided by c. Okay, so if I have, again, log of some base, and then I have division inside the logarithm, then I can go ahead and break that up into separate logarithms with subtraction. Okay, dividing that, or subtraction separating each of those logarithmic terms. Okay, so that is my quotient property. So then I'll go ahead and I'll just put all the properties up here. So we've got product property that we went through, quotient property, and our power property of logarithms. Okay, what our power property shows is that if I have log base A of x raised to some power, okay, so A and x are not the same thing in this instance, okay, raised to some power, that's equal to whatever that power is. I can kind of bring that to the front, okay, as like my coefficient for this logarithmic term. So that's going to be equal to whatever that power is times log base A of x, okay? So go ahead and make sure you have all three of these written down. Make sure you understand what they're all called. So if you're asked to refer to any of them in a specific problem, you know which property to use. All right, so let's go through a few examples here. Okay, we're being asked to use, we're given that log base 4 of 2 is 1/2, okay, or 0.5. Now we're asked to approximate the value of log base 4 of 32, okay? So what we're going to do is we're going to try to rewrite this log base 4 of 32 in a way that we can kind of use this information up here, okay? So what we're going to do here is I'm going to say that log base 4 of 32, that's equal to log base 4 of, I'm going to break apart this 32 into 4 squared, because 4 squared is 16, okay, times 2. Okay, so now we're using our product property, or we're going to use our product property, because I've got 16 times 2 ultimately in my logarithm, okay? So I know, since I have this multiplication, and again, it's got to be inside the logarithm, okay, now I can break this apart and say log base 4 of 4 squared plus log base 4 of 2, okay? That's all I'm doing, going back to our product property. Now we know that log base 4 of 4 squared, that's going to simplify to just 2, okay? Because again, this is saying log base 4 of 4 squared, how I can kind of think of that. That's going to be 4 to what power equals 4 squared, right? Okay, and again, if this is true, I've got the same base here, so then that power has to be 2, right? Okay, so this is just going to be 2 here, all right? And now we just got to figure out what log base 4 of 2 is. We're going to use the same logic here. Log base 4 of 2 equals what? I don't know. So this is the same thing as saying, okay, 4 raised to what power equals 2? Well, 4, taking the square root of 4 equals 2, right? See when it comes up, there we go. Okay, so taking the square root of 4 is the same thing as raising 4 to the 1/2 power. Okay, so our question mark here, that power that we're trying to find, is 1/2. Okay, so we are just going to add on. So this ultimately is equal to this 1/2 here. Okay, so we're going to add 1/2 to our 2. And our final answer here for our value of log base 4 of 32 is going to be 2 plus 1/2, or 2.5. Okay. All right, now let's take a look at our quotient property. All right. Okay, the pH of a substance is defined as the concentration of hydrogen ions in moles. It is given by the formula pH equals log base 10 of 1 over H plus. Okay? Find the amount of hydrogen in a liter of acid rain that has a pH of 5.5, all right? Okay, 5.5. So we're going to go ahead and use this formula that we're given. And what we're trying to find here, we're trying to find our H+. Okay, that is our concentration or the amount of hydrogen in this liter of acid rain. All right. Okay, so we're given that our pH is 5.5, so we can go ahead and rewrite our equation with 5.5 substituted for our pH here. Okay, and then I've got division inside my logarithm. Okay, so I can go ahead and rewrite this as the right-hand side is going to be log base 10 of 1, okay, that's what we have in our numerator, minus log base 10 of our H+. That's what's in our denominator. Okay. Now I know log with any base of 1 is going to be 0. Okay, so log of any base of 1 is 0. Okay, so that goes away, and then the rest of our equation stays the same. Okay, so now I've ultimately got 5.5 equals negative log of H+. Okay, so we can go ahead and I'm going to divide both sides by negative 1 here. Okay, so I'll have negative 5.5 equals log base 10 of H+. Okay, and then I'm going to go ahead and bring in this base of 10 here. Okay, so I'm going to basically take what I have as my original equation and bring those into the exponents of some base. And since this log has a base of 10, I'm going to bring in a base of 10 here. Okay, and when I do that, what happens here on the right-hand side of my equation? Well, hopefully you remember that here, this is going to ultimately, this base 10 and this log base 10 are going to cancel out, and I'm going to be left with just H+ on the right-hand side of my equation, okay? Which is what we are trying to find, which is great. Okay, so I've got 10 raised to the negative 5.5 power is going to be my concentration or my amount of hydrogen in a liter of acid rain. And if we wanted to find that decimal points in moles, okay, that's going to be, if you plug this into your calculator, that's going to be 0.0000032 moles, okay? All right, taking a look at another example using our power property. Okay, again, we're given log base 3 of 7 is approximately this value, 1.7712, and we're asked to approximate log base 3 of 49. Okay, so again, we want to rewrite this 49 in terms of 7 if we can, which is easy enough for us because 49 is equal to 7 squared. Okay, so I'm going to rewrite this as log base 3 of 7 squared. Okay, so now if I'm taking a look at log base 3 of 7 squared, well, our power property says that I can move this 2, okay, and again, my base and what's inside my log do not have to be equal to each other. Okay, so I can move this 2 now out in front of my logarithm, right? So it's now kind of the coefficient of this logarithmic term. Okay, so we know now I've got 2 times the log base 3 of 7. Well, I know what the value or the approximate value of log base 3 of 7 is because it's given to me up here. Okay, so this is going to be 2 times what this value is for log base 3 of 7. And when I plug that into my calculator, I get 3.5424. Okay. All right, the last example here, we're going to look at logarithmic equations. Okay, we're asked to solve for x. Okay, log base 6 of x plus log base 6 of x plus 5 equals 2. Okay, now let's think of this using our using our product property here. Okay, so I've got log base b of x plus log base b of y. Okay, I've got the same bases here, is equal to log base b of x times y, right? Okay, well, right here, this x is sort of my x, and this x plus 5, I can think of that as my y, right? So I can rewrite the left-hand side of this equation as log base 6 of x times x plus 5, okay? So think of this as x times y. That's really what we've done here. And I don't change anything with the right-hand side, that just stays 2. All right, so then I'll go ahead and I'll again bring in this base of 6, and I'm doing that because I have this 6 right here. That's the base of my log, okay? So I'm bringing my original equation up into the exponent of this new equation with the base of 6. And then my base of 6 and my log base 6 are going to cancel each other out, and I'm left with just x times x plus 5 is equal to 6 squared, which is 36. Okay, and then I can go ahead and distribute my x here, and I get x squared plus x plus 5, sorry, x squared plus 5x, okay? And then I subtracted 36 from each side. So now I've got x squared plus 5x minus 36 equals 0. And from here, hopefully we know how to solve this. We're going to go ahead and factor the left-hand side. Okay, so this is going to be x plus 9 times x plus 4 equals 0. And when I solve for x, I get x equals negative 9 and 4. Okay. Now, one thing we have to be careful of, okay, we need to check any domain issues with our original problem, okay? Because what happens if I take log base 6 of 9, of negative 9, sorry, log base 6 of negative 9, I can't have a negative inside of this, inside of my log, okay? I cannot have this negative in here. That's going to be undefined for us. So negative 9 is actually not going to be a solution for us. The only solution we have is going to be x equals 4, okay? So be careful there when you're solving these logarithmic equations. Make sure that the solutions you get don't provide any domain issues, and in which case they would be extraneous solutions. So we would not count those for our final solution set, okay? So x minus 4 is our solution there. That's all I got for this video. Good luck with your practice.